This segment is on spinal reflexes. A reflex is a rapid automatic response to a stimulus. Reflexes can make rapid adjustments in the function of organs or organ systems. Each time a particular reflex is activated, it will produce the same motor response. A reflex will always involve a receptor that detects a stimulus, an integration center where a synapse will occur and information will be integrated, and an effector that will react to the command given. Spinal reflexes range in complexity from simple monosynaptic reflexes involving a single segment of spinal cord to polysynaptic reflexes that involve many segments. A monosynaptic reflex is a simple reflex where there is very little delay between the sensory input and the motor output. The best known monosynaptic reflex is the stretch reflex, which provides automatic regulation of skeletal muscle length. The patellar reflex is an example. When a physician taps your patellar tendon with a reflex hammer, the patellar tendon is stretched. This stretches the quadriceps tendon, and receptors in the quadriceps muscles are stretched as well. These receptors are called muscle spindles. The distortion of the receptors in turn stimulates sensory neurons that extend into the spinal cord. These sensory neurons synapse on motor neurons that control the motor units in the stretched muscle. This leads to a reflexive contraction of the stretched muscle that extends the knee in a brief kick. All monosynaptic reflexes involve only one single synapse. A polysynaptic reflex can produce far more complicated responses than monosynaptic reflexes can. In a polysynaptic reflex, interneurons are involved and can control several muscle groups. These interneurons can either stimulate or inhibit action potentials in the central nervous system. A withdrawal reflex is an example of a polysynaptic reflex. The strongest withdrawal reflexes are usually triggered by painful stimuli. In this example, the stimulus is the pain experienced when grabbing a hot frying pan. The response is a contraction of the flexor muscles of the arm. The contraction causes the forearm and hand to be yanked away from the pan. The movement is sudden and powerful enough that the pan is released. The sensory neuron synapses on an interneuron which will synapse on the motor neuron, leading to the flexor muscles of the arm, and will also ascend in the columns to the brain. All synaptic reflexes involve interneurons and multiple synapses.